So I've been talking quite a bit about like the repelling and attractive effects of gravity and the sun and the way solar mechanics work in general. So it's been brought to my attention, and thank you for bringing it to my attention, that there's differences when the seasons change on planets like Jupiter was the case in study. So they're saying that when the planet or when Jupiter tilts, that one hemisphere actually slows down just a small percentage. So I'm going on this assuming that this is true, okay? And it was reported that, if it's reported correctly, it was reported that the two satellites, Cassini and I believe it was Voyager, noticed these changes. So it's being confirmed if it's proper reporting. So why is that happening? There's two possibilities from the way I see it. One, because like I was talking about, the nature of electricity or the nature of energy, the way it works and the way it actually repels other energies. So when the top hemisphere is closer and the bottom hemisphere is further away, that's going to make the mass at the center move away from it. And that's that. And it's also, this is the other subject I want to talk about. So I'll just put two in one here. That mass is actually what creates spin of celestial bodies. That energy not naturally wants to try and get away from the other energies out there, such as like the star in this example. And then it's a continuous effect because it repels from itself in the core. It's kind of a sophisticated system. So anyway, so when that planet shifts, or when any planet shifts, when there's room in there, if it's not compressed enough, it will go to the opposite side or as far away from the other, the stronger electric output point. You know, kind of clean this up for me, guys. It gets away from that part, so that's the part that keeps spinning, and so therefore what's spinning underneath there would speed up faster and speed up the mass. The other possibility to solve that issue would be quite simply that the plasma, quote unquote, I call it gas, the gases of the upper atmosphere of Jupiter are actually pulled to the star. So the gases in that area are going to linger there longer. And so that would be the other reason why it slows down, maybe. I'd go with option A on this one, guys, but, you know, putting two out there for you. What do you think? Should I make a separate video for the celestial body spin? Because the way that works is if you got, if, you know, the mass wants to get away from itself, so it wants to spin, it spins itself away, and that keeps everything, all the above layers, spinning as well. And so, yeah, pretty simple stuff. There's something else there I was going to mention. Can't remember off the top of my head. Catch you on the next video, guys. This is, it's harder to do, unscripted and, you know, unedited and stuff like that. So, yeah. See you later.